So this is the oscilloscope, and right now I have it powered on. We can power it off. It's this switch right up here on the top that you push in. Lots of very cool functions. It's kind of like a universal remote because it has so many different buttons. It's hard to get used to. And it's set up really nicely to see our sine wave here really, really well. And it looks really good. You notice this channel 1 light is lit up, and that's because it has two channels right here and here. And right now we can only see channel 1. If I turn on channel 2, which is connected to nothing, you can see a blue waveform comes up here, and that blue waveform is just 0 because nothing is connected to it, because nothing is connected to this plug right here. But we can see them both at the same time if you'd like, which is kind of the point of this oscilloscope. So we have channel 1 and channel 2, and there's lots of stuff that we may want to do on this. Back in the day, what they had to do is the oscilloscopes were analog instead of digital, and so they'd have to look down here on the yellow channel. It says that every division is 2 volts, so every square vertically is 2 volts, and so they'd have to come up here and count ticks. So they'd say that's 2 volts, 2.2, 2.4, 2.6. That's at about 2.6 volts at the top. It's about 2.6 volts at the bottom, or 2.5 volts at the bottom. Yeah, 2.6. And I take that back. Each one of those ticks is going to be about 0.4 volts. So 2.4, 2.8, 3.2 volts. So that's about 3.25 volts for that, because this next tick up here is 4 volts. And so they'd have to measure it that way. We have some cooler things. And what I want to point you to is this cursor button. Right now it's off. And so when I press the cursor button, it brings up a menu right here. And so when we look at this, I want to switch it to track. And so that's the one we want. Let me go back to track. And what it has two cursors, and let me demonstrate. There's one of them. You can see I control it with this knob here, and it's moving right to left. And then I can switch and press cursor B, and there's another one that comes over here. The other setting that you should be aware of is channel 1 versus channel 2. You can look now, and now I'm on channel 2. On cursor B is on channel 2, so or cursor A, so I'm going to switch to cursor A. You know, it's tracking the blue now. Well, what's really cool about this is that if I switch back to channel 1, it tracks that. Not only does it track it, but it tells me my voltage. So if I want that very bottom peak, cursor A, the X, it says, is at minus 100 microseconds time, but minus 3.28 volts. And that's about, we said it was about 3.25 volts is what we estimated it to. It says that this other marker B, is at 2.88 volts, and it's not quite at the peak. That's why. So these numbers here tell us a few other kind of interesting things. One is it tells us delta X, or the amount of time between this point and this point, is 156.0 microseconds. It also tells us the delta Y is 6.16 volts, and that bounces around just a little bit. And so this is a really useful tool because we don't really have to guess anymore where that cursor is. We can just move it to the right spot, and it will tell us exactly what the difference is between this. This is 6.4 volts approximately between this point and this point. And so this is really handy to be able to measure some voltages. Obviously this is going to change if I come over here to my signal generator and change. You can see my difference in voltage has jumped up to 12.2 volts now. And so this is going to be the kind of things we do. The cursor menu is one that you want to get familiar with, though, because what it's going to allow us to do is measure differences in X and Y, and also this horizontal scale. So one thing that we can do, vertical scale, one thing that we can do is if I select channel 1, so I can either be on channel 1 or channel 2, and this lights up accordingly. So right now I'm selected channel 1, and notice I didn't change this knob over here. I'm changing the knob of scale over here, and you notice that this changed. Now there's 10 volts per click on this, which means we're about 5 volts there. And so we can make it off the scale, and this is one of the ways we see. And sometimes you come up to the scope and it looks like this, and you have no idea what's going on. And so it just takes an adjustment on that portion. There's also a knob over here that's the horizontal scale. You notice that there's a thing here that says 200 microseconds. That's how much time is between this across that square. And I can adjust that. As I adjust it, now it's at 2 milliseconds. So you can see I have a lot more waveforms there. And let me see if I can get it to a point that you come up to the scope and you're just like, I don't even know what that is. Well, you can start messing around, and I'd suggest that you get used to messing around with these signals. And maybe it just doesn't work. You start messing around. You can't really break this thing by pressing the buttons, is what I'm trying to say. And so maybe you start, you start realizing that was really big. Well, that was really nice to be able to do that, and I'd suggest that you get used to that. And there's also something here that will adjust the horizontal and vertical position. So you can see I adjusted the horizontal there, and then I can scroll this left and right just a little bit. Well, if you come up to a scope and it's not showing exactly what you want, you can press the easy button, which is this auto button up here, and it'll bring up the waveform as best it can. You notice it turned off channel 2. It brought up this menu, and it tells us it shows us our frequency of that sine wave right there. And so there's lots of bells and whistles on this that we can do, and then we can continue to adjust it how we want it to. We can turn on the cursors to track mode, and then we can move the cursors around to wherever we want them to be to make the measurements that we need to be. And maybe we want to do it here. There's one other thing that we can do with this is we can run and stop it. So this is live data. This is data that's moving right along. We don't have anything, we can't see it. It's moving so fast. That's why we need the scope. But it's able to display it to us in this. And just to give you an idea of what would actually look like is this is what it would look like if we tried to look at it with our naked eye without the oscilloscope. I'm just going to adjust that back. You don't have to worry about that too much. But there's also this run stop button, which freezes it in that moment in time. And so that's something that can be really useful to see something in a moment in time. You also notice for future that there's a USB slot here. And so we can record the data, not just the image, but also the data, so we can look at it in another program. So that's a general overview of the oscilloscope. I think the biggest thing here is there's no possible way that you can break this by pushing buttons. There are ways you can break it if you connect the probes incorrectly, but you can't break it just by pushing the buttons. So don't be afraid to mess around with it, to try to figure out what it does. It's just a big universal remote that you have to get to know.